Alright, today's lesson is about properties of rhombuses, rectangles, and squares. So these are shapes you've probably learned a little about back in the day. However, we're going in more depth and more detail on these shapes. The first one is a rhombus. Now, one thing I want to show you is that these are all types of parallelograms. So all these shapes are types of parallelograms. That means they all share one specific property. What's the number one property on a parallelogram? Opposite sides are parallel. So all these shapes have opposite sides parallel. All of them do. But they do look a little different when you start looking at them individually. A rhombus, I'll draw over here. That's traditionally how it looks. And the key fact on this one is that it's a parallelogram with 4 congruent sides. A rhombus is a parallelogram with 4 congruent sides. Now, we'll talk about some additional properties of all these shapes here in a little bit, but let's get through these basic shapes. A rectangle, we know what a rectangle looks like. And what's the key fact you think you should remember about a rectangle? 4 90-degree angles. So it's a parallelogram with 4 right angles. After that, we have a square. What property should we remember about a square? 4 congruent sides and 4 right angles. It's a parallelogram with 4 congruent sides and 4 right angles. So basically, a square steals the properties from a rhombus and a rectangle. So a square is a type of rhombus, and it is a type of rectangle. A square is a type of rectangle. Now, I mentioned that there were some other properties that they all share. See if you can look at those pictures and think back to parallelograms. What other properties do they share with parallelograms? They all have 4 sides, so these are all quadrilaterals. Not exactly a property, but it's a true statement. What other properties? Yep. Okay. All of them have opposite sides are parallel. Sorry, let's do opposite angles. Opposite angles are what? They are congruent. So opposite angles are congruent. We do know another one about opposite sides. Opposite sides are what? Are congruent. Any others you can remember? Oh, we had like 5 or 6 yesterday. I'm only seeing 1, 2, 3, 4. We have more. Diagonals bisect each other. Good job. Did you remember a different one, Connor? Yeah, we got that one. Yep. Any others? You can look at your notes from yesterday. I think we have one more for some reason, but I'm going blank. One pair of opposite sides congruent. That just means it's a parallelogram. Yeah, so we'll stop there. We'll stop there. So it has 1, 2, 3, 4, 5 properties. Oh, one other one that someone just said was interior angles add to 360 degrees. That's a great property to remember. All right, on this next one, we have example 1. It says, for any rhombus, we're focusing on the shape rhombus. Decide whether the statement is always or sometimes true. Draw a sketch and explain. So I definitely suggest being able to do these without kind of cheating yourself, without looking at these solutions. So try to remember back to a rhombus. And what does a rhombus look like? Well, it should have 4 equal sides, something like that. If we call it R, S, T, V, we got to describe, will this always or sometimes be true? S and V, will they always be congruent? This is going to be an always. What's the explanation? It says draw and explain. Why is it always? Great. This shape will always have that property that says opposites, angles are congruent. Awesome. Now if we do that picture again, R, S, T, V, it says T and V. Is that always or sometimes? It's going to be an always or sometimes because it's only giving us 2 choices, one or the other. It is not a never. This is actually going to be a sometimes. So on this picture, it seems like a never. However, we got to remember that another shape shares the same property as a rhombus. What was that other shape? Square. So I need to be examining a square. If we look at a square and we call that R, S, T, V, can V and T be the same? Sometimes. Why? A square. Yeah. A square is a type of rhombus. So write that down. A square is a type of rhombus. Example 2 says classify that special quadrilateral and explain your answer. So look on this shape over here. We have one angle is 127. We have 4 sides are congruent. Automatically, I'd be focusing in on those 4 sides congruent. What properties have that, or what shapes have that property? A square and a rhombus. So it's one or the other. It's either a square or a rhombus. Most people can get to this point. Now, it's obviously not a square because, yeah, it doesn't have 90s. So this is a rhombus. Explain your reasoning. What's our reason? 4 congruent sides and no right angles. It would help differentiate your answer. That'd be great. All right, on number 1, it says for any square, CDEF, it's always sometimes true that CD is congruent to DE, and explain your answer. So let's examine the picture real quick. If we have a square, C, D, E, and F. Those are all the some of the basic properties of a square. Is it true that CD is congruent to DE? Is that always or sometimes true? That is definitely an always. Why? Yeah, it always, so a square always has 4 congruent sides. It's good. On number 2, it says a quadrilateral has 4 congruent sides and 4 right angles. What kind of quadrilateral do we have? That's a square. That's just a square. Why is it not a rhombus? Oh, it doesn't say it. It says 4 congruent angles. So if it has 4 congruent angles, can it be a rhombus? So rhombus, can these 2 angles be congruent? Nope. So it's not a rhombus, it has to be a square. Has to be a square. Alright, now we have some new properties about these shapes. And these are the ones that people have the most trouble remembering. Because they're new, they're different. They don't make as much sense immediately. But if you look at them and remember them and you study them, you'll be okay. So on a parallelogram, it's a rhombus if and only if its diagonals are, what are the diagonals? What do you notice about them in there? What's that symbol right there mean? It's a right angle there, and when 2 lines form a right angle, they are perpendicular is the key word. When their diagonals are perpendicular, it is a rhombus. So what are the 2 perpendicular pieces? AC and BD. Alright, Theorem 812. It says a parallelogram is a rhombus if and only if its diagonals bisects a pair of opposite angles. So a lot of times you all were trying to go and look at these parallelograms and say whenever you had the diagonal drawn, that's bisected. And I can obviously tell that that's not a true statement. However, if you have a rhombus, it is a true statement. A rhombus has a ton of symmetry. So we know that a lot of angles are going to be bisected, and a lot of angles are going to be congruent whenever you have the diagonals. So this is a rhombus if and only if AC bisects what angle? AC bisects which 2 angles? Yeah, BAD is bisected. And then how do we name this one with 3 letters? BCD is a good name. And then we have the other diagonal. I'll color it in blue. If we have that diagonal drawn, this angle right here is bisected. What do we want to call it? Probably ABC. And what do we call the other one? CDA works. So a lot of times we like to write out our own property, our shortened little property to the side. What's our short little property for this one right here? On a rhombus, diagonals are perpendicular. This is only for a rhombus. So on a rhombus, diagonals are perpendicular. What's the statement for the next one? What are the diagonals doing? Bisecting angles. So on a rhombus, the diagonals bisect angles. So those are our shortened little properties. All right, the last one deals with not a rhombus but a rectangle. So we're going to have a shortened little property for this rectangle. So it says a parallelogram is a rectangle if and only if its diagonals are congruent is the key word. We already know they bisect each other because that's a property it steals from a parallelogram. But in this case, they're actually congruent. So diagonals are congruent. So what are the 2 congruent pieces? AC and BD. Another shape that shares the same property is a square. It has the most symmetry. On example 4, it says you're building a frame for a painting. The measurements of the frame are shown at the right. The frame must be a rectangle. Given these measurements, can we assume that this shape is a rectangle? All right, so Given the measurements, we only know stuff about the sides. We only know opposite sides are congruent. Not all sides are congruent. Can we say that it's a rectangle? And the answer is no. We can't assume it's a rectangle. Why? We don't know the angles. We don't know if it has right angles. Which was the major property of a rectangle. On part B, it says you measure the diagonals of a frame. The diagonals are 25.6 each. So here to here and here to here. Those pieces are 25.6 each. What can you conclude about the shape of the frame? So, can we prove that it's a rectangle now? Yes. Yes, this is a rectangle. And why is it a rectangle? The diagonals are congruent. So in real life, to actually do this on like work sites, to make sure a foundation is square, meaning it has 90-degree angles at its corners, they'll measure corner to corner, and they'll make sure they're the same. When people are making picture frames, that's what they do to make sure the picture frame is square. This is a very useful technique to make sure you have 90-degree angles. All right, try checkpoint number 3. Sketch a rectangle and list everything you know about it. Try to do this without looking at your notes. All right, so real quick, we need to be able to sketch this shape, and then from there, we'll start doing our properties. So I'll cheat a little bit. I'll do my perfect rectangle. So there's my rectangle. Basic property. What's the number one most basic property of a rectangle? Right angles. It has 4 right angles. So I can quickly add those in. What's another property? Somebody raise your hand. Yes. Diagonals are congruent. So that's all the way across, all the way across. Those are equal. Somebody else raise your hand. Yes. Opposite sides are congruent. Diagonals bisect each other. Yes. Consecutive angles are supplementary. Yes. Opposite sides are parallel. Okay. Interior angles add to 360. So opposite angles are congruent. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8 properties.